Hi everyone. Today let's talk about section 5.5, substitution rule. Big idea. Integration by substitution is a formal way of performing the chain rule in reverse. So it's very similar to the chain rule, but chain rule is for derivative, and the U-substitution is for the integrals. Big skills. You should be able to calculate the integral using substitution. So before we start, let's recall for a definite integral, we have the fundamental theorem of calculus. Okay, so the definite integral equals you calculated the antiderivative, and then you plug in the upper limits of integration b, and then you plug in the lower limits of integration a. Okay, and notation. To denote the set of all antiderivatives of f, we use indefinite integrals. So you can see the definite integral gives us a number, and the indefinite integral gives us a family of antiderivatives. Okay, so this is a family of functions. Okay, so here are the antiderivative formulas. We talk about that in section 4.8. So integral of x to the p equals to x to the p plus 1 over p plus 1. And don't forget plus c. Integral of cosine is 1 over a sine because the derivative of sine is cosine. Integral of sine is negative cosine because the derivative of cosine is negative sine. So when you differentiate, you multiply by a because of u prime chain rule. But when you integrate, you're going to divide it by a. Okay? So integral of secant squared is tangent, but you multiply by 1 over a in front. Integral of cosecant squared is negative cotangent. Integral of secant tangent is secant. Integral of cosecant cotangent is negative cosecant. Integral of e to the ax is e to the ax divided by a. Integral of 1 over x equals to ln of absolute value of x plus c. Integral of 1 over square root of a squared minus x squared, that is the arcsine of x over a plus c. Integral of 1 over a squared plus x squared equals 1 over a arctangent of x over a plus c. Integral of 1 over x square root of x squared minus a squared is 1 over a times arcsecant absolute value of x over a plus c. Okay, so here are all the antiderivative formula that we learned. Okay, so here is an example. So remember for integral, we say we don't have product rule, we don't have quotient rule. So if we have something like this, what do? Okay, we can only apply the power rule. So let's distribute everything. So we multiply it out. 1 plus x squared is 1 plus 2x squared plus x to the 4th. Here we're using the formula a plus b squared is a squared plus 2ab plus b squared. And a minus b squared is a squared minus 2ab plus b squared. Okay, and then we distribute it. So we have x plus 2x to the 3rd plus x to the 5th, okay? Then we can integrate each term. Integral of x is x squared. We add 1 to the exponent and divide it by the new exponent, which is 2. Plus 2, so constant multiple 2 stay here. And then x to the 3 plus 1 is 4, divided by 4. Plus x to the 5 plus 1 is 6, and then over 6 plus c. Okay, and we simplify it, and this is the answer we get. Okay, so this is what we do when we have a square. But in general, what if we don't have a square? We have a 50. What do? Do you really want to multiply out and then use the power rule? No, it takes hours to do that, maybe days to do that, okay? So that's why here we can use the substitution rule to solve this integral, okay? So can you see this guy? This guy is a composite function, right? It's 1 plus x squared to the 50. Okay, so when you see composite function, think about U substitution. So let U be the inner function. So always let U be the inner function. Okay, like a derivative. Where G prime is continuous on an interval, and let F be continuous on the corresponding range of G on that interval. Integral of F of G of X, G prime of X dx equals to integral F of U du. Okay, why is that? If you can remember chain rule, well, we have dy dx equals to dy du times du dx. Right? And let's integrate both sides with respect to x. So integral dy dx is the integral dy du times du dx. Okay? On the left, you can see dx cancel. We have integral of dy, but it's like 1 dy. So the answer is y. On the other side, we can see dx cancel. We have integral of dy du. Okay, and this is exactly this picture. So dy du is f of u, okay, and then du is on the right hand side here. Okay, all right, so this is how we integrate. So far so good, everybody? Okay, so let's continue. All right, so how do we solve this problem? So first of all, we're gonna let x be let u be the inner function. So we let u equals to 1 plus x squared. Okay, so let u be the inner function. And second, find du. So here, let's differentiate the u equals to 1 plus x squared, okay? You should get like du dx equals to derivative of 1 is 0, derivative of x squared is 2x, okay? So this is a derivative. But I want to have a differential form. What is differential form? Well, you can multiply both sides by dx. This is a differential form. Okay, and then this is the second step. So it's from now on, when you use U substitution, you don't need to write this. Okay, you just do the differential form. Okay, so you have du on the left, and then you have dx on the right. Okay, and then the third step, we're gonna change this integral in terms of the u. Okay, by the way, here you can see du is 2x dx, so x dx is then 1/2 du. So now when you plug in, do you see x dx? Well, that is 1/2 du. You put it at the end. And then this guy 1 plus x squared is u, so that's u to the 50. Well, 1/2 is a constant multiple, right? We can move it outside. And then what is the integral of that? Well, this is like the third step. Okay, we put it in and express in terms of an integral about u. Okay, we add 1 to the exponents, so we have u to the 51 over 51 plus c, right? And at the end, 2 times 51 is 102. We put our x back. So the fourth step, put our x back. So u is 1 plus x squared to the 51 plus c. So this is the final answer, okay? Let's summarize what we have done. First step, okay? First step, we let u be the inner function. Second step, we define what's du. Du is g prime of x dx. And then 3, we get the new integral with respect to u, and let's solve that. And the fourth step, put the x back, okay? Put the x back using u equals to g of x. So those are the 4 steps. Let's look at the first problem. Okay, so usually you let u be the inner function. So if you have a fraction, you usually let u be in the denominator. But here you can see here, while the denominator we have square roots, but don't let u be like a square root. Let u be the things inside the square roots. Okay, so let u be x squared plus 3x minus 1. And then what is du? Well, the derivative of x squared is 2x. The derivative of 3x is 3. And don't forget dx. Wow, what happened? Can you see that's exactly the top guy, right? So the top guy is du. So our integral equals integral of du. And then we have the square root of u. So far, so good. So you have to, so you either have an integral about x or you change everything in terms of u. You cannot have like some terms like you have a du here, but you forget to change the u here. No, you cannot have something like this. You either have an integral with x, with respect to x, and you either have an integral with respect to u. You cannot have a mixture. It's like you don't want to drink milk and orange juice together, right? So you don't want to drink a mixture of milk and orange juice. So please make sure you either have an integral of x, everything is x in terms of x, or integral about u, everything is in terms of u. Okay? So let's continue. This is u to the minus 1/2 du. What do? Power rule. We add 1 to the exponent, so it becomes u to the 1/2. Sorry, after we integrate it, don't put the integral sign. And then divided by 1/2, that's the same as multiply by 2. And then SC. Okay? And the fourth step, put our x back after we finish integrating it. Okay? So our u is x squared plus 3x minus 1. U to the 1/2 is like square root of x squared plus 3x minus 1 plus c. Or if you want to put x squared plus 3x minus 1 to the 1/2, that's the same. That's okay. You don't have to put like the square roots. So that is example 1. Okay, so far so good, everybody? Let's continue. So I hope you can pause the video here and try to work on part B. Are you done? Let's check our work. So here, what's u? So you can see, we let u, and then you also see there is some factor in the integral that's like the derivative of u. Can you see here? This guy is like, ln of x and times 1 over x dx. Can you realize 1 over x is the derivative of ln of x? So then this should be the u, and then this guy, 1 over x, will be the du. Okay? So be careful. Don't let u be x. Never do that. Because if you let u be the x, you just get the same integral. See? Like here. When you let u be x, or you just have ln of u over u du. You just change the name of the variable. You're not doing anything like interesting to it. Okay? So never let u be x. Okay? And sometimes I see students put the du in the denominator. That won't happen. Your du is always on top. Your du won't be in the denominator. Okay, so this problem, first step, let u be ln of x. Second step, differentiate both sides. So we have du, and this is 1 over x dx. So don't forget to write dx. It's like two kids are playing a seesaw, so you cannot leave. Yeah, you have to have the two kids to play the seesaw. Otherwise, we cannot play the seesaw, right? So don't forget the dx. Alright, and then the third step, our integral becomes ln of x, that's u, 1 over x dx, that's du. Oh, let's integrate that. Well, that is u squared over 2 plus c. What is u? U is ln of x. So far, so good, everybody? Yeah, so this is our answer. We put the x back. Okay, so follow the 4 steps. And then, next, also please pause the video here and try to work on part C first. What do you let u to be? The inner function, okay? And sometimes when you let u be the inner function, there are also some terms, factors in the integral that is like du, okay? Can you see like x is the derivative of x squared? So yeah, we let u be x squared plus 1, okay? On top, the exponent of the exponential function. And then du is 2x dx. But we don't have 2x dx, we have x dx. So what's x dx? Divided both sides by 2. So 1/2 du. Okay, so what is the integral? Well, the integral x dx, that's 1/2 du, but remember 1/2 is a constant multiple. You can put it outside. And then we have e to the u. So far, so good, everybody? So what's the integral of e to the u? After we integrate it, don't put integral sign. So that's e to the u plus c. And what is e to the u? U is x squared plus 1. Yeah, we get it. So far, so good, everybody? Alright, let's continue. Okay, so let's continue to look at part D. Well, part D, well, what's the inner function? Well, we usually look at the denominator, right? And we have the square roots. So let u be things inside the square roots, x plus 1. Okay, then what is du? Or dx, right? Okay, let's try to plug in. So dx is du. And we have the square root of u at the bottom. But I still have x. So I still have x. What is x? Well, here. What is x? X is, so look at this guy. When we solve for x, x is u minus 1. So plug in here, u minus 1. Okay, so this problem is harder than the previous examples because instead of just putting in u and du, you have like sometimes x. Then you have to solve for x in terms of u and figure out what is that. Okay, so let's continue. So is a quotient. Do we have quotient rule? No. So we split. So that is u over square root of u minus 1 over square root of u du. Okay. So next, what is u over square root of u? So u is like square root of u times square root of u, right? So u is square root of u times square root of u. So you cancel one copy of the square root of u. You still have square root of u. And what's square root of u? That's u to the 1/2. Okay, and then 1 over square root of u is like u to the minus 1/2. Okay, integrate. Add 1 to the exponent divided by 3 times 2. Add 1 to the exponent, so u to the 1/2 divided by 1/2 is like multiplied by 2. Finally, plot our x back. U is x plus 1. U is x plus 1. Okay, so this is our final answer. So far, so good, everybody? Alright, let's continue to look at part E. Okay, so first of all, you can see this function. So this function is a improper fraction, right? Improper because the degree of the numerator is greater or equal to the degree of the denominator. So when we see this improper fraction, we should use long division to simplify it. Okay, simplify it first. So what is that? Well, okay, long division, 4x cubed plus x squared minus 3x plus 5. Okay, divided by 2x plus 3. What is that? Well, what multiplied by 2x to get 4x cubed? Well, that is 2x squared, right? Then we have 4x cubed plus 6x squared. Use the first line, subtract the second line. X squared minus 6x squared is negative 5x squared. And then what's next? Okay, wow. What multiplied by 2x to get negative 5x squared? Negative 5 over 2x. Then I get negative 5x squared, and then negative 15 over 2x. Okay, use the first line, subtract the second line. What do we get? We get the first one get cancel. Okay, that is like negative 3x plus 15 over 2. So 15 over 2 minus 3 is like 6 over 2. 15 minus 6 is 9. So 9 over 2x plus 5. Okay, and what multiplied by 2x to get 9 over 2? Well, that is 9 over 4. So then we have 9 over 2x plus 3 times 27 over 4. 5 is like 20 over 4. So we get negative 7 over 4. Okay, so our integral becomes, okay, so we have, this is the quotient. This is the divisor. This is the remainder. Okay, long division tells us that this guy equals to the quotient plus the remainder over the divisor. So far, so good. And you can see that this guy is just polynomial. We can integrate polynomial. Well, that is 2x cubed over 3 minus 5 over 2, x squared over 2, and 4 over 9x, right? We can integrate polynomial. And then that guy, we can put the 7/4 in front of the integral. So far, so good, everybody. And then, what do we do next? Okay, so here, this guy, we're gonna do the chain rule. U-substitution. Chain rule is for derivative. U-substitution is for integral. Okay, so let's calculate what this is. Okay, we let u be 2x plus 3, and then du is 2 dx. Well, this guy, okay, let's call, so just this guy, not including the coefficient in front. So dx, well, dx is then 1/2 du, so we get 1/2 du, and then we have 1 over u. Oh, that is ln of absolute value of u plus c. And u is 2x plus 3. So our final answer equals to 2 over 3 x cubed minus 5. 2 and 2 is 4. And then 7 over 4 times 1/2 is 7 over 8. ln of 2x plus 3 plus c. Okay, so that is our final answer. Okay, so it might happen that some parts of the integral you can integrate it, okay, with the formula. And when you get to a step that some part of the integral you cannot integrate by the formula, then you think about the U substitution. Okay? All right. Let's continue. Okay, so let's look at this problem. What do we let U to be? Well, when we see a fraction, we think about let U be the denominator, okay? And you can also notice that, well, this is x squared. The derivative of x squared is sort of x. So maybe we can let U be the denominator and the numerator will give us du, right? So let U be the denominator. And then du is 2x plus 1 dx. Okay, let's see. Wow. Can you look at our function? Our function, can you see a common factor 3 on top? Then we have 2x plus 1 dx. The bottom is x squared plus x plus 1. Wow, then the top is exactly 3 stay there. 2x plus 1 dx is exactly du. And then x squared plus x plus 1 is actually u. Wow, this is 3. Integral of 1 over u is ln of absolute value of u. And what is u? U is x squared plus x plus 1. Okay, and plus c. So far, so good, everybody? Okay, let's continue. So let's look at part G. Okay, so let's look at part G. You can see here. So let's use our first try, okay? So first try, we see we let u be x squared over plus 4, like what we did in the last example. Let u be the denominator, and then du is 2x dx. Okay, which is not exactly like the numerator. What do we do in this case? You see, this is only x dx, okay? So it only involves x dx. So it suggests us maybe we can split this guy and this guy. So we can split them, and then we get 3x over x squared plus 4 dx plus 5 over x squared plus 4 dx. So actually this guy, we can use U substitution to solve. And this guy is the formula of arctangent. You see, the denominator is x squared plus some constants. That corresponds to the formula of arctangent. Okay, what's the formula of arctangent? That is 1 over a arctangent of x over a plus c. Okay, so that's the formula of arctangent. You can see they're so similar. Okay, so this part we use U substitution. And so it was x dx. Well, that is 1/2 du. Okay, so let's call this guy J. Okay, then J equals to 3 over still there. And then we can put the 3 out in front actually. X dx is 1/2. We can put the 1/2 in front. And then we have 1 over u. Right, everybody? So that is 3 over 2 ln of absolute value of u plus c. And what is u? U is x squared plus 4. Questions. Why don't we put the absolute value here? That is because x squared plus 4 is always positive. So we don't need an absolute value for that. Okay, and so finally our answer equals, let me use a different color. Okay, so our answer equals j is 3 over 2 ln of x squared plus 4. Okay, and plus we can have plus c at the end, so you don't need plus c here again. So 5, we can put out the 5, okay? And then we have 1 over x squared plus 4. 4 is like 2 squared. So we use this formula when the a is 2. So 1 over 2 tangent of x over 2, and then we have the plus c. Okay, so that is our answer for this problem. Okay, so far so good. So you have fraction. First of all, you want to see whether it's proper. If it's not proper, okay, so let me write it down. So if you have fraction, you want to ask, is this proper? If yes, then you can look at the terms. So you either do U-substitution, or sometimes it's related to odd tangent. Okay, so sometimes you might need to split. You might want to split. Okay, and if it's not proper, use long division. Okay, use long division first, so that you can express our quotient into terms of a polynomial plus the remainder over the divisor. Okay, so for a polynomial, we're able to integrate when we have a remainder and divisor. This guy is proper. Then you can go back to either like split the integral, use U-substitution, or arctangent to solve the problem. Okay, so far so good, everybody. Okay, now please pause the video and try to work on part H. Okay, are you done? Let's check our answer. So here, what do we let u be to be? Inner function. So which is 2 minus 5x. Well, then du will be negative 5 dx. So far, so good. But we just have dx. So dx is negative 1 over 5 du. Our integral becomes sine u. Dx is negative 1 over 5. We put it in front. Du. Okay, what's the integral of sine u? Well, it's either positive cosine or negative cosine. Then you think about the derivative of cosine is negative sine. So the integral of sine is negative cosine. So negative cosine u plus c. Well, negative become positive. And what is u? 2 minus 5x. Okay, so this is the floor set. We plot our x back. So far, so good. So this is a U-substitution, and we work on for the indefinite integral. Okay, in video part B, let's solve the integrals with definite integrals, with bounds. So we're supposed to get numbers, okay?